Welcome back, wonderful people. This is Mr. Ndabezita, and we are looking at the derivatives of trigonometric functions. And the very first one we will look at is the derivative of the sine function. Right, they say to calculate the derivative of f at x equals sine x for x which is measured in radians, we combine the limits in the theorems that we have dealt with the sum identity for sine functions in order to find this derivative. So meaning we are simply going to use the first principle. So if we have, or if we are told that f at x is equals to sine x, and we want to find dy over dx using first principle, we would recall that if we use the angle sum identity, that would become the sine of x plus h. Why? Because remember, we will be using first principle, and we always say that h should be equals to 0. So we will have this. Right, and we know by using the sum identity of sine, this would be sine x cos h plus cos x sine h. So therefore we will say f prime of x is equals the limit as h approaches 0 of f at x plus h minus f at x divided by h. Right, and you would keep on writing your limit as h approaches 0. We dealt with this many times when you dealt with the grade 11. Right, and then your f would be your sine, and your angle where you see x, you'll be writing x plus h, minus the function, your f at x is sine x, all be divided by h. Very important. And we would continue to say the limit as h tends to 0. Now we would use the sum identity of sine here, as to say sine x cos h plus cos x sine h minus sine x, which is this one, all be divided by h. And we can continue the limit as h approaches 0. Now I want you to check something here. I can group this with this so that I can take out a common factor. So sine x cos h minus sine x plus cos x sine h, all be divided by h. So what have I done here? I have grouped this with this. There it is, and I still have my cos x sine h. Very important. Now I can take out a common factor here, in here, which is sine x, and I'm left with cos h minus 1 plus cos x sine h, all be divided by h. Very important stuff. And we can continue in this. Now what I can do from there, remember this h divides in here and also divides there. So this is one thing that I can do also. So meaning I can try and say, okay, the limit as h tends to 0. So what I can say there is to say, okay, let me in here, I want to draw your attention here. After this, what I can do there is to say, okay, I have my sine x multiplied by this. So what I'm going to do there, because look what is happening here, this h should divide here and also divide there. Do not forget that grade 6 rule in mathematics. So I have sine x times, therefore I'm going to say cos h minus 1 all over h, very important, plus, so meaning I'm taking the limit on both, because remember the limit here, because h divides this, and I'm splitting this. I'm splitting this into sine cos h minus 1 over h plus the limit as h tends to 0 of cos x sine h over h. So please be very careful there. I'm introducing the limit here dividing by h, introducing the limit there dividing by h. So I'm going to say the limit as h tends to 0, and I'm also going to say here cos x times sine h over h. I hope you see this. Where does it comes from? From here. From here. So I'm introducing the limit of cos h times sine h over h, because this h divides here and also there. Please do not be confused in this. Alright, and then from there, what is it that I can do? Because there's multiplication here. I want you to be very careful. I can factor out the sign. So meaning I can have sine x, the limit as h tends to 0. Now I'm left with cos h minus 1 over h, because I factored this out. Then the limit of this, which is probably the same thing. Plus I can also factor out cos. So cos x, the limit as h tends to 0 of sine h over h. And then what is it that we can do from there? Now you would recall, if you have watched my tutorials, that the limit of this, the limit, if you draw the graph of this, you would saw that the limit, or you will see that the limit of this is equals to 0. So you will have sine x times 0 plus, and the limit of this is equals to 1. So you would have cos x times 1, which is equals to cos x, because this is 0. Cos x times 1 is cos x. So meaning dy over dx of sine x is equals to cos x. This is one fundamental rule that you should know.